Hello everyone, this is Aisha Naz and today our lecture will be on the topic Universal Turing Machine. So we'll be going through what is a Turing machine, then Universal Turing Machine and its working, and then few examples along with the applications from the research papers. Okay, so before covering what is a Turing machine, you must know what a Turing thesis is. Now, Turing thesis says that every task performed by a digital computer can be performed by a Turing machine. Like any task, any question, any problem you are performing by a digital computer that can be performed by a Turing machine. And this machine was basically proposed by Alan Turing in 1936. And what's interesting about it is that the concept of Turing machine came way earlier when the um, actual digital computer were discovered and they were invented basically. So this idea of Turing machine, they came before the digital computers, which is so fascinating. Now, the Turing thesis, the concept of Turing thesis, which says कि कोई भी हमारे पास any task which will be performed by a digital computer that can be performed by a Turing machine. Now, when we are making a Turing machine, we will be making for a particular problem, and then that particular Turing machine will be solving a particular problem. The second Turing machine will be solving another problem. So can't you see the contradiction? Like a digital computer can perform any sort of problem, but with the Turing machine, with one particular Turing machine, we can only perform a particular sort of problem. So here is a kind of like the thing which is very contradictory, and to solve this arises the concept of universal Turing machine. If we talk about the few uh, things of what constitute a Turing machine, then we must know about this head. This is the pointer. It can go left, it can go right, and where it is standing, it can read what's there, and it can also write, means change anything. Then this long thing is kind of a tape which has the infinite memory, and it is divided into, you can consider them as cells. Then these are the blank spaces, and here will be our symbols. Now coming to the universal Turing machine, universal Turing machine can simulate any other Turing machine on any input, and then it will be giving us the outputs, whatever outputs what a Turing machine which is simulating in that universal Turing machine is giving. So it can solve any sort of problem. Now, the characteristic will be simulation, means you can incorporate any sort of Turing machine in a universal Turing machine. One simulation. The second is universality, means one machine can perform any computation that any Turing machine can perform. And why it is happening? Because you can simulate any Turing machine in universal Turing machine. Then foundation, because this concept, the concept of Turing machine, is the foundation of many modern computers and interpreters and virtual machines. So that's one of the characteristic here. Now, in universal Turing machine, we have got the concept of multi-tape, because here we have three different tapes, what so far we know, and one for the representation of Turing machine, other for the inputs and outputs, and another for the maintenance, or the to keep the track of the internal states. Coming to how a universal Turing machine works, first of all we will encode what a Turing machine which we have simulated is. Okay, and for that we will be using the tape number 1, which is representation of the Turing machine. The second step will be to encode the word, any word which we are taking from any language. The word here we are taking like W. We are taking W from any language L, and that we are encoding in the machine. The next step is simulating. Simulation means what transition can be performed on that particular input, on that particular state. Okay, then track states. In universal Turing machine, keep the track of machine's current state using the reserve tape region, which was using the third tape, which was internal states, which were for the internal state, for the tracking of all these states. And the final will be, if the UTM halts when machine would halt, then it is accepting and rejecting. So it's sort of thing. If it is accepting, then we halt the machine. Then comes a few examples. Example number one is unary number increment. Mean after each like operation, after each computation, there will be the incrementation of 1. Okay. So the Turing machine, at the start we have 3 1 1 1 1, and then we have got the blank spaces. Now what will this Turing machine do when it starts? These are the steps, these are the algorithm steps. Okay, when the Turing machine starts, tape start at 1 1 1. Okay, it will read, then the head will move to right until it finds a blank space. Now as soon as the head moves and it finds the blank space, it will write 1 on that first blank space. As it says here, write a 1 in blank, in that blank space. Okay, and then move left, means come to this particular position again, and you're done. Results will be 1 1 1, and the machine halts, and yeah, we have got our output. Example number one is string copying. Now this is our input, and for example in string copying we want another output like this same. Okay, this on this input we want this output. So what will it do? First of all, mark the leftmost uncopied symbol with X, which is this one. Okay, it will mark this as X. Then move right past hash delimiter to find writing position. Now it will move right past all these symbols to find this particular delimiter, to find the position where you want to start writing your copied string. Okay, and then the first the leftmost uncopied symbol that you have marked with X, you need to remember that one. Okay, and that remembered X will be written on the position after hash, and then return left, and this goes on till you are completed with all the symbols and reaches this delimiter. Then you know that you have completed your task and the machine halts there, and we are good to go. The next is palindrome checker. It decides if the particular string is if the particular string is palindrome or not, right? So first of all, what we'll do, that we'll read and erase the leftmost symbol, and also what is the most important point here is that remember it. Okay, we will read it and erase it and also remember it. Then we'll move to the rightmost position, which is this one here. Okay, we'll move to that rightmost unerased position, and we'll see if that's the same. If it matches, then we are good to go to the next position, and if it does not match, then the machine rejects. After completing our applications, after completing our examples, we are going to go through the applications that I have taken from few of the research paper. The number one application I have taken from a research paper which was basically written in 2017, and is on the implementation of the universal Turing machine with DNA strand. Now here these DNA strands work as the data, and what all these computations and all these chemical reactions happening with this with this DNA strands, those reactions, consider them as computations. So that's how they are working. And so far what I have researched, this research paper is based on the nature nanotechnology, and see, scientists are actually building Turing machine using DNA. Then another application from the research paper 2014. And one thing I've noticed here in this research paper, it also mentioned that deep minds are also uh, involved in this research. It is on the neural Turing network, means here we are involving the neural networks with the Turing machine. Like neural networks, you might think of a controller and all these, controller sort of thing. And for the memory, we have tapes. So this comes here. And then another application number 3 is quantum universal Turing machines, which was written almost from 2020 to 2023. And this particular research paper talk about the combination of the quantum physics and Turing machine. Like imagine Turing machines working with the quantum physics and all. So this using Turing machines with the quantum physics and all these things, this really stimulate the process. Like the classical process is very slow, and using this sort of approach, it actually makes the algorithms and working very way too fast using this approach. So this was all about it. We have covered so far what the Turing machine is, Turing thesis, and then universal Turing machine, uh, and few examples, and also the uh, applications. So I hope you get it, and thank you.